Hi everyone. Welcome to our the new week, which will be on sampling. We're gonna talk broadly about how people or units are selected into a study. It's typical in research that you can't study everything, so you need to sample. You need to take a part of the world to focus on, to measure. And then it turns out the way you do that influences, in many ways, the interpretation of the study's findings, and also its your ability to generalize from a particular study. So here's an overview of topics. We'll begin with that issue I just mentioned of generalizability. Then we'll talk about basic sampling concepts. We'll talk about some problems and biases that come up in sampling. We'll talk a little bit about non-probability sampling, which some studies use, and then random or probability sampling, which is more rigorous in some ways, and then some variations of random sampling that are used in practice. So random sampling in practice includes some additional variations that make sampling both kind of interesting but also intricate in a way. So let's start by thinking about this idea of generalizability. In many ways, when you look at a study and a particular study's findings, what's of interest to us is really not necessarily the particular people or situation in the study, but what that study has to say about our broader world, or about us, or about our communities, or our programs. So generalizability is the notion, or it really refers to the extent to which a study's findings hold true outside of or external to the particular context of the research. And we need that to be, we need to make some judgments about that, because otherwise we're just reading a study about a particular group of people who happen to be in the study, and and that may be interesting in one way, but we really care about it most of the time because we want to apply it to a broader world. And because it refers to sort of the extent to which a study can be generalized outside or external to the findings of a particular study, it's also generalizability is also referred to as external validity, meaning the findings hold to what extent do they hold to a situation external to the study itself. That's what a study aims to do. It aims to, or that's what we hope studies do, is they inform us about a broader world, and then we refer to that as generalizability. To what extent is a study generalizable beyond the particular people or context that was actually investigated? Now, there are a couple things that influence the generalizability of a study. One is the population of interest. Some studies aim to investigate broad national or even international populations to begin with, but other studies are much narrower, just in focus or definition. I mean, we may be interested in a particular population or a particular subgroup of a population. So that's something to keep in mind. What population is the study interested in to begin with? And then there's the issue of sampling, and how was the sample drawn? And just up front, I'm just going to mention here that probability random sampling tends to be more generalizable than voluntary or convenience samples. So as a general rule, well done probability samples are more, studies that are based on that kind of sampling are more generalizable than studies based on voluntary or convenience sampling. But it all depends. There are lots and lots of variables that go into that. So, for example, random sample from a very narrow population may not be as generalizable as a voluntary sample from a much broader population. So there are ways in which that general rule may not hold in every situation, but still, generally, random samples are better for generalizability than voluntary or convenience samples. Now, interestingly, experiments are often generalizable, despite the fact that they're typically not done with probability samples, and that's because they focus on causal relationships. And it turns out that relationships can often be generalized more confidently than more descriptive characteristics. So I'll give an illustration of that. Also, replication is a way that generalizability can be enhanced. So replication is the idea that a study can be repeated with a different sample or in a different location or a different time period. So variations on the setting or the program or the treatment, if it's a consistent finding across multiple replications, that enhances our confidence in the generalizability of a study. And there's a formal way of doing that, which is called meta-analysis. Meta-analysis is a method for pooling together multiple small studies, and in many fields where there are many studies of, let's say, one treatment or one program or one type of intervention, authors may or researchers may pool those analyses together in the form of what's called a meta-analysis and try for sort of a more generalizable conclusion about the effectiveness of that particular intervention or treatment. So there have been meta-analyses, for example, of early childhood education programs, meta-analyses of job training programs, meta-analyses of psychotherapy, and certainly in the medical field, many meta-analyses of different treatments of different kinds, like cholesterol medication and that kind of thing. So are relationships more generalizable? This is the point I made about experiments being generalizable. Relationships are often more generalizable than descriptive findings, such as percentages or means. And this is one of the reasons that experiments are often generalizable, even though they depend typically on volunteers. It's important to point out that experiments and relationships can have generalizability limitations due to unrepresentative samples. This is sort of something to think about, but it's not a hard and fast rule. In other words, it doesn't mean that every study that looks at an experiment, every study that involves an experiment or that looks at a causal relationship is automatically generalizable. It again, like with all aspects of research, it requires a lot of judgment. But as a general rule, there's ways in which relationships tend to be more generalizable, and the best way to point that out is to illustrate it. Now, this is the example we give in the book. You might not quite have followed it. It's a little subtle the way it works, but let me explain what this is. So it turns out that to illustrate this, we use some data from a worldwide survey called the World Values Survey, and it measured both health and happiness in countries all around the world. There's some 40 or so countries that are included in this survey, and what we're showing you here in the table is the mean level of health on a 0 to 100 scale, and the mean level of happiness on a 0 to 100 scale, where we take all nations, which is nearly 55,000 individuals, and then we compare that to the mean for just the one landlocked Eastern European country of Moldova, which is 974 people were interviewed in Moldova as part of this study. Now, as you can see, the means are quite different, right? The mean health index is 71, almost 72 for all the nations, but it's only 50 for Moldova. And similarly, the mean happiness level is about 79 for all countries in the world, but it's only about 51 for Moldova. So Moldova's, if we were just looking at the descriptive characteristics, the findings from Moldova are not a good indication of what can be generalized to the rest of the world, right? So Moldova's descriptive levels of health and happiness are not generalizable to the rest of the world. But let's look now at the relationship between health and happiness. So this graph shows that. It's a correlation. Correlations are correlation coefficient, it's called. It's a measure that goes from 0 to 1. It can be either positive or negative, and it shows the extent to which health and happiness are correlated. And we might expect, of course, that being healthy leads people to be happy, or alternatively, having health problems leads people to be less happy. And if we look at this correlation, interestingly, in Moldova, it's about 0.34, just a little bit less than 0.3, or rather a little bit more than 0.33. And that's a fairly strong positive correlation. So healthier people are happier in Moldova. But then if we look at the world overall, all the countries that were surveyed, the correlation is surprisingly similar. It's 0.333. So health and happiness are correlated all around the world. So, and this kind of makes sense. It makes sense that maybe individual people may be less happy and less healthy in a underdeveloped country like Moldova, but the connection between health and happiness may be more consistent or more universal, more generalizable, basically, when we look at even just one country like Moldova. So this is just a simple illustration of the fact that sometimes correlations or relationships between two variables can be more generalizable than the descriptive statistics of the variables that make up that relationship. Okay, now we're going to quickly go over some basic sampling concepts. Most of this is in the book and you can read it, but it's useful just to kind of review. Sampling, it's important to start with the notion of the population or universe that the study aims to get at. I mentioned that earlier. It's important to point out that when researchers use the word population, it doesn't always refer to a general human population. For example, there can be a population of air for air quality monitoring, or for sampling fish in a study of the oceans. There's a population of fish. Could be a population of buildings if we're sampling buildings in order to do, let's say, a building inspection. So population just refers to the totality of elements or units or things that you want to make conclusions about. Now, so there's a population out there of something, of people or of air or of buildings or whatever, and then you need to sample from that population because you don't have the resources to include the whole population in the study. Although it can happen, and by the way, when that does happen, it's called a census, not a sample. But a sample then is a subset of people or elements that are selected from the population, and so we're going to talk a lot about that and how it happens, how we pull that subset or pull the sample, and then or draw the sample, and then we make inferences. We measure the sample, we collect data, and then ultimately we want to make an inference back to the population. And so the notion of inference and generalizability are tightly connected. Inference is a more statistical way of saying that you're making a conclusion about the population based on the data. So here's a diagram from the book that describes the process. Here's the population that we might be interested in. We draw a sample from that population. That's the sampling process, either using non-probability or probability sampling. And then we gather data on that sample. We observe some findings. And then the idea is to make an inference back to the population. Another way to say that is to generalize back to the population. So those two ideas are pretty closely linked. Okay, just finally, as I mentioned, sometimes a study does not involve sampling. There are some populations that are small, and it's possible to gather data on the entire population. So let's say our population of interest is some after-school program. We have lots of kids in the after-school program, but not that many. We may have 100 or so. And it may be just as well to gather data on all of them rather than sample. So this is referred to as a census. A census, many of you may think of the national census, like the U.S. decennial census, the U.S. census, and most countries around the world have some kind of census, at least periodically. That means you try to gather data on all the citizens, all the people in a country. But census refers to any kind of data collection in which you take or gather data on everybody. So if a school system takes or tests every single kid or almost every single kid in the school system, that would be called a census. Or if we survey all the parents, let's say, of children in an after-school program, that would be a census as well.